To quote Nelson Mandela, quote, "Education is the most powerful weapon which you can use to change the world," end quote. The question is, how much did you know about our own star that we call the sun? This video will help you learn a little bit about our sun. By the way, the data in this video is largely inspired from nasa.gov website, and the animation are just for visual and learning purposes and do not reflect all the realities and complexities of this topic, so please don't take it too seriously. Our sun is a 4.5 billion year old star, a hot glowing ball of hydrogen and helium at the center of our solar system. The sun is about 93 million miles or 150 million kilometers away from our planet Earth. This distance Sun-Earth is also called 1 astronomical unit. The sun is the largest object in our solar system. The sun's volume will need 1.3 million Earths to fill it. If the sun was as tall as a typical front door, Earth would be about the size of a nickel. NASA and other international space agencies monitor the sun 24/7 with a fleet of solar observatories studying everything from the sun's atmosphere to its surface. And to learn more about our solar system, don't forget to subscribe to my YouTube channel and stay tuned on what's coming next. You can check my courses like the Amazon Leadership Principle course or the course on a brief introduction about America and a lot more. Links in the description below. Here are some space missions to keep in mind. NASA Parker Solar Probe. Launch date August 12, 2018. NASA Parker Solar Probe is on a mission to touch the sun. The spacecraft is flying closer to the sun's surface than any spacecraft before it. The mission will revolutionize our understanding of the sun. To perform its unprecedented investigations, the Parker Solar Probe and its instruments are protected from the sun by a 4.5-inch thick or 11.43 centimeter carbon composite shield which can withstand temperatures reaching nearly 2,500 degrees Fahrenheit or 1,377 degrees Celsius. On December 14, 2021, NASA announced that Parker had flown through the sun's upper atmosphere, the corona, and sampled particles and magnetic field there. This marked the first time in history a spacecraft had touched the sun. During its journey, the mission will provide answers to long-standing questions that have puzzled scientists for more than 60 years. Why is the corona much hotter than the sun's surface, the photosphere? How does the solar wind accelerate? What are the sources of high-energy solar particles? Parker can survive the sun's harsh conditions because cutting-edge thermal engineering advances protect the spacecraft during its dangerous journey. The probe has 4 instrument suites designed to study magnetic fields, plasma, and energetic particles and image the solar wind. The mission is named after Dr. Eugene Parker, who pioneered our modern understanding of the sun. Next mission, SOHO, which stands for Solar and Heliospheric Observatory. Launch date December 2, 1995. SOHO is the longest-lived sun-watching satellite to date. Numerous mission extensions have enabled the spacecraft to observe 2 11-year solar cycles and to discover thousands of comets. SOHO is an international project between the European Space Agency and NASA. SOHO monitors the effects of space weather on our planet, and it plays a vital role in forecasting potentially dangerous solar storms. SOHO is the most prolific discoverer of comets in astronomical history, with more than 3,000 tracked during encounters with the sun as of September 2015. December 2020 marked the 25th anniversary of the Solar and Heliospheric Observatory or SOHO mission. Next mission, GeoTel. Launch date July 24, 1992. GeoTel monitors the long-tail regions of Earth's magnetosphere. GeoTel provides information about the way the magnetic envelope surrounding Earth, called the magnetosphere, responds to incoming materials and energy from the sun. Surviving more than 6 times longer than planned, GeoTel continues to send back crucial data. This mission is a cooperation between Japan and the United States. GeoTel's goal was to study the structure and dynamics of the long-tail region of Earth's magnetosphere, which is created on the night side of Earth by the solar wind. During active periods, the tail couples with the near-Earth magnetosphere and often releases energy that is stored in the tail, activating auroras in the polar ionosphere. Next mission, Solar Orbiter, launched on February 9, 2020, is a joint mission between the European Space Agency and NASA to collect data that will help answer a central question of heliophysics. How does the sun create and control the constantly changing space environment throughout the solar system? The sun creates what is known as the heliosphere, a giant bubble of charged particles and magnetic fields blown outward by the sun that stretches more than twice the distance to Pluto at its nearest edge, enveloping every planet in our solar system and shaping the space around us. To understand it, Solar Orbiter is traveling as close as 26 million miles from the sun inside the orbit of Mercury to measure the magnetic fields, wave, energetic particles, and plasma escaping the sun. Solar Orbiter launched from Cape Canaveral on an Atlas V411 rocket on February 9, 2020. It now follows an elliptical orbit around the sun, completing one revolution every 168 days. Solar Orbiter joins NASA Parker Solar Probe in studying our star from closer than any spacecraft before them. Working together, Solar Orbiter's comprehensive suite of instruments and NASA's Parker Solar Probe's up-close view of the sun provide a never-before-seen global view of our star, the sun. Other active spacecraft monitoring the sun include NASA's Advanced Composition Explorer ACE that collects and analyzes particles of solar, interplanetary, interstellar, and galactic origin. Launch date was August 25, 1997. Next mission, the Interface Region Imaging Spectrograph, IRIS. IRIS is a NASA Small Explorer mission to observe how solar material moves, gather energy, and heats up as it travels throughout a little understood region in the sun's lower atmosphere. IRIS was launched on June 27, 2013. Next mission, Wind Spacecraft, comprehensive solar wind laboratory for long-term solar wind measurements. Wind is a spin-stabilized spacecraft launched with a Delta II rocket on November 1, 1994. Next mission, HINOD. HINOD explores the magnetic fields of the sun in order to improve understanding of what powers the solar atmosphere and drives solar eruptions. Launched on a Japanese M5 rocket on September 23, 2006, the HINOD mission is a collaboration between the space agencies of Japan, the United States, the United Kingdom, and Europe. Next mission, SDO, the Solar Dynamics Observatory. SDO will study how solar activity is created and how space weather comes from that activity. Launch date was on February 11, 2010. Next mission, STEREO. Launched in October 2006, the Solar Terrestrial Relations Observatory, or STEREO, has provided scientists a unique and revolutionary view of the Sun-Earth system. Composed of two nearly identical observatories, one ahead of Earth in its orbit, the other trailing behind, STEREO has traced the flow of energy and matter from the sun to our planet Earth. Like all stars, our sun will eventually run out of energy. When it starts to die, the sun will expand into a red giant star, becoming so large that it will engulf Mercury and Venus and possibly our planet Earth as well. Scientists predict the sun is a little less than halfway throughout its lifetime and will last another 5 billion years or so before it becomes a white dwarf. You can learn more about our sun at solarsystem.nasa.gov. And to quote Tracy Drain, a NASA flight system engineer, quote, "The important thing about being a scientist or an engineer is learning how to think critically, learning how to be creative, learning problem solving, and learning how to learn." Thanks for watching and goodbye.